Hi, hello, welcome to my channel, Chemistry Rocks. Yes, chemistry will surely rock if we are very sure with what we are studying and how we are practicing. So let us quickly get into the topic. So I'm discussing now the third type of reaction, students, displacement reaction. So in this video, I'll be quickly covering the definition of displacement reaction, children, and how the reaction of displacement takes place. That is, it's based on a series called reactivity series, and we'll also discuss few examples. So let's quickly start the topic. So now I'm going to demonstrate how a displacement reaction is taking place. So let me take the example of a boy A and a boy B. Okay, so here I have drawn the picture of the two boys, and if you can clearly note, there's some difference between the two, right? So boy A and the boy B. So boy A is a little strong and the boy B is a little weak. So now what will happen here is the boy B didn't know. He's new to the class. He didn't know that it is A's place, and he just went and sat on his chair. Okay. So the boy B has sat on the chair of boy A. Okay. So now what will happen? Boy A is really angry. What will he do? He'll quickly go push the boy B from the chair, pull him out or push him out, and he'll try to displace, or he'll try to just push him out and he'll sit in his place. So this is how anything when it is strong or anything when it is weak, um, the normal thing occurs in our daily life. So here, if we have seen boy A is sitting in is trying to displace boy B from the chair, right? C is the chair here. So he's quickly going, pushing the B out and forming AC, that is A is sitting in the chair and B is moved out. So this is what is a displacement reaction. Very easy, right? So here, which one is stronger, children? Boy A or a boy B? A is stronger than B. So here, if you can check, if the element which is alone, or the metal which is alone is displacing the metal which is weaker and which is in a place. Okay, so what is this place? Let us quickly see with the help of the definition. This is the definition, children. Displacement reaction is a reaction in which a more reactive element, okay, a more reactive element will displace a less reactive element. From where will it displace? Like from the chair example we had, right? There should be some place. So that place is nothing but salt or aqueous solution. Okay, so it should be a solution. It should be a solution where a solute and solvent will be present. So it is most probably a solvent with water. That's how we call it as an aqueous solution. Okay, so here the displacement takes place where a more reactive element, okay, a more reactive element is displacing a less reactive element from where? From the salt solution. So most of you write the definition only till here and forget from the salt solution. So please never make that mistake. Okay, I would like you all to write the entire thing till the salt solution or the aqueous solution. So let us learn this quickly with the help of an example, children. So you can see here iron nail is kept in copper sulfate solution. Okay, iron nail is kept where? In copper sulfate solution. So copper sulfate solution, if you have already observed the color, it's blue. Okay, so copper sulfate solution is blue in color. So whenever you get any colored salt or any colored solution, I would like you all to write with that color pencil or sketch pen, so that while you are studying it will be quickly noted down in your mind. So here if you can see, children, solid is the iron nail, okay, whereas the copper sulfate solution is aqueous. Aqueous means it is taken in water. Copper sulfate is taken in water. So slowly, when you just leave it for some 10 or 15 minutes, you'll be seeing that iron, being more reactive than copper, will just go and push the copper out. Okay, it will tell, hey, I'm more reactive than you. So just move out. So iron sulfate will be formed, your children. Okay, So iron sulfate is actually pale green in color. Okay, I think pale green color is this. Okay, so here I would like to write iron sulfate with pale green color only. So iron sulfate is formed along with the copper being displaced out. Okay, so if you can see, a blue color solution is turning to pale green color. Okay, so why is this change taking place? Is because copper sulfate, which is aqueous, which is blue in color, is turning to iron sulfate, which is aqueous and pale green in color. Okay, so this is the solution color, pale green color of iron sulfate. So here, iron being more reactive, children, is displacing the copper sulfate. Okay, so this is how we define a displacement reaction. So now let us quickly see how will we know that which one is high reactive and which one is low reactive. So here in chemistry, we have a list of elements which are well proven by the scientists, and they have proven it in their labs and told that this is the list of the elements from higher reactivity to lower reactivity. So reactivity series, they can ask an exam for you to define. It can be a 1 mark question, and they can ask you examples. It can be together a 3 mark question. So a reactivity series is a series or list of elements, children. So most probably in this list we have metals. Okay, so you can also say it's a list of metal which are arranged in lower order of reactivity. So lower order of reactivity means it's clear, right? It starts from higher reactivity to lower reactivity. Okay, so this is how the reactivity series is. So reactivity series is very important if you want to understand the displacement reaction. Reactivity series should be known to you. So how will we, mug up? In other words, I can say reactivity series. So I have a very easy method for you to remember this reactivity series, children. Okay, so this is the way. Please stop calling me a zebra in the library. Hydrogen, call me something good, please. Okay, I'm repeating it once again. Please stop calling me a zebra in the library. Okay, here the sentence ended. So hydrogen came out. Call me something good, please. So here the first letter you can take and you can place it the name of the element. Okay, so the first letter I have been taken and calling it the element name. So P means potassium, S means sodium, C means calcium, M magnesium, A aluminium, Z zinc, I iron, T tin, L lead, hydrogen, and then C copper, M is mercury, children here. Sorry, M is mercury. Okay, and S is silver, G is gold, and P is platinum. Okay, so this is the reactivity series. So if you can see, it's the top ones are of higher reactivity. Okay, these are the higher reactivity, and the bottom ones are lower reactivity. Okay, and you can see the bottom ones are almost the elemental form where you take it in the form of ornaments. So silver ornaments, gold ornaments, platinum ornaments. We all have seen it in our daily life, right? So these are all ornaments. So higher reactivity to lower reactivity, we have arranged the elements. So very easily we can remember this with the help of the reactivity series, and this is the easy way to remember. So make a note of it. So potassium, children, I hope you all know the symbol. It's K. It's kalium. It's a Latin name. Sodium is Na. Ca is calcium. Mg is magnesium. Al is aluminium. Zn is zinc. Iron is Fe. Tin is Sn. It's again a Latin name. Stannum. Lead is Pb. Hydrogen is H. Copper is Cu. It's cuprum. Latin name. Mercury is Hg. Hydrogen. Again a Latin name. Silver is Ag. Argentum. Au is gold. And Pt is platinum. So in this way, we have arranged all the known elements in the reactivity series. Okay. So this is very, very important. So for any reaction to take place, we should check with the reactivity series. So for example, I have taken zinc in copper sulfate solution. Zinc solid, I have taken an aqueous solution of copper sulfate. So now I have to check. What should I check? Should I check zinc is more reactive or copper is more reactive? I should check zinc is more reactive because this is the strong boy A, which is going and displacing the weak boy B. So zinc should be more reactive. A should be more reactive than B. So zinc is pushing the copper out and sitting in its place or not. Let's check in the reactivity series. So zinc is somewhere here, children, and copper is here. So obviously zinc is on the top. It's high in reactivity. So it's forming zinc sulfate plus copper. So I want you all to check the colors and comment in the chat box. What are the colors? Okay. What is copper sulfate color? And what is the zinc sulfate color? So what is the color change, in other words, in this displacement reaction? Similarly, let us write another displacement reaction, Ag plus CuSO4. Okay, I have taken a solid Ag, that is silver. Ag is silver, I hope you all know. Copper sulfate solution. Copper sulfate solution is aqueous solution, which is blue in color. Okay, so will this reaction take place? Let us check if Ag is more reactive or copper is more reactive. So copper is here and Ag is here. So Ag is less reactive, children. It's not more reactive, it's less reactive. So simply we'll just write no reaction. Okay, no reaction. No reaction means it will just remain as it is. There will be no change happening, no color change, no bubbles formation, nothing. So this is how the displacement reactions takes place. So I want you all to go through more and more of displacement reaction in the textbook. So always remember, you should check whether this single element is more reactive than the element which is present in the salt solution. Thank you for listening to me patiently. Please like, subscribe, and comment. If there's any doubt, anywhere you're finding any difficulty, please do reach me out. Please do comment. I'll be very happy to answer all your questions. Thank you.